myself. I'm Nick, the executive head of Alwyn and Courthouse. We've got Mr. Little. Mr. Little, do you want to say hello?
Hi, everyone.
And we've also got Miss Pulsford. Miss Pulsford, do you want to introduce yourself in case some of our guests don't know who you are?
Yeah.
Sorry, Mrs. Godding, not Miss Pulsford.
Don't worry. Year 3 teacher and also the maths lead for Courthouse.
Excellent. So we have Miss Little, head of school, and Mrs. Godding, who used to be called Miss Pulsford. Mrs. Godding is our maths leader and year 3 teacher. This evening, we want to share with you some advice, some tips, some guidance on supporting children with maths. This follows on from our session a few weeks ago, where we did the same for reading. We think maths is equally important. We want children to come to school loving maths, enjoying maths, feeling that they're good, feeling successful, so that they are in a position to do well when they leave us in year 6 in a few years' time. We'll show you the outline of what we're talking about today. So we're going to talk about 3 things. The first is about mathematical fluency, what it means and why this is important. Then Mrs. Godding particularly will talk a bit more about how children become more fluent and how we can support them to be quick thinkers, to be able to solve problems and to do well in any maths lesson at school. And then I'll finish off by talking about the difference that parents can make in the little things at home that really do support what children learn at school. So over to you, Mr. Little, for the first section.
Thanks. So I'm going to talk about why fluency is important. It's something that we teach at school and is a good way that parents can help support at home by trying to make their child more fluent in maths. What that means is being able to recall and calculate number facts. We're going to focus on number facts specifically, but all facts related to maths, so children become automatic at them, and the speed of what they're doing is also really important. So we're looking for speed and accuracy when we speak about fluency, so children can quickly recall any question or any number fact or fact linked to maths that we ask them. And because maths is hierarchical, it's a subject where you need to learn some things before others, or in order to learn other things, you need to learn things before. We decided to structure the session at the kind of the lower end of the maths pyramid, and all of the things that we explain can be scaled up. The things that we're going to explain, your child might have been taught how to, or will have been taught how to do at Key Stage 1 and in year 3 and year 4 and year 5 and even year 6. But all of the things we're going to talk about are foundation things that you can practice at home in order to make your child more fluent, because the more fluent your child is, the quicker they can then access everything in maths. It will allow them to apply their knowledge and solve problems quicker, answer questions quicker, and be able to make more progress, which is doing more and remembering more. On the slide on the screen is part of our maths curriculum, but also the kind of pyramid that I referred to. We're going to be talking about the bottom row today, and the importance of the bottom row, those foundations. If children can't do some of those things, the further they go up the pyramid, the further they go up in their school and their education. If there are gaps in their knowledge, it makes it harder for them to apply that knowledge when they're faced with a question. So we're going to be talking a lot about number bonds, a lot about subitizing. Counting is something you can do at home really easily, and calculations with doubles, and then that's the foundation layer. Once your child can do that, they can then move on higher up the pyramid. Becca's going to talk about how children can become more fluent in maths, and some things you can do at home.
Okay, so moving on, we're going to start by talking a little bit about number bonds. When we refer to number bonds, we're meaning pairs of numbers that make up other numbers. And you probably have commonly heard teachers talk about number bonds to 5, to 10 and to 20, but we also need to focus on the number bonds within those. So on the screen you'll see number bonds within 5 there. You've got addition facts, subtraction facts, and also missing number facts. And children need to be able to be flexible with those and move between them really quickly and really easily. It looks very simple, but when we ask children, they need to be recalling those within seconds, to make sure that they can access other things. The number bonds there are systematic, so you need to work through them in the sort of order that's on the top of the screen there, and we're going to talk about some really good ways to practice those, but orally practicing at any opportunity in sort of quick bursts is ideal, and that's what we do a lot in school.
Becca, where, let's say we've got children or parents in year 3, what would we expect them to be able to do either now in year 3 or by the end of the year?
So certainly by the start of year 3, we would expect number bonds within 5 to be secure. That means within and 2, and also to 10, really. By the end of the year, we would definitely expect to 20 to be fluently recalled, and we would be pushing children to go to 100 as well. Okay, thank you. So these are some representations that we use in school a lot. We use bar models, which are at the top there, and also part whole models at the bottom. These models really help children to understand their facts and the links between them, the relationships between addition and subtraction. So, for example, in that top bar model, they should be able to derive that 7 add 3 equals 10, 3 add 7 equals 10, and also those subtraction facts, 10 take away 7 is 3, and so on. So they're really useful representations and models to use, and they're used throughout from year 3 all the way up to year 6. They're always used, and like Mr. Little said earlier, they can be scaled up with other facts in maths lessons. Have I missed anything there?
Just to say, Becca, that for parents, that bar model at the top, again, it seems quite simple, but when children progress up the school into year 4, year 5, year 6, it's this bar model that becomes more and more complex and more necessary for children to understand harder concepts such as fractions and ratio and proportion, and to solve other problems. So again, although it looks simple, it really is fundamental to children's understanding of maths going through Key Stage 2.
Absolutely. So that links in nicely with Numbots, which I'm sure you're familiar with. The children all have access to Numbots. It's an online game where they can work through levels that are very carefully designed, and they help children to recall their addition and subtraction facts. It also shows lots of representations like the ones on the screen and like you just saw that we use in lessons. And the children love it. The more questions they answer, the more coins they get, and they can go to the shop and use these coins, which is always a highlight for them. We have got some slides just to show you what Numbots looks like if you haven't seen it in action. So this is the sort of home screen that your children will have. There are 2 modes, and the first is story mode, which is the sequence that we want children to be working through. And this has numerous levels, starting at the very basics and moving throughout. The aim is for children to be achieving accuracy on these, so they should be getting 3 stars each time they have a go at these tasks, and also to be answering them quickly. They won't progress through them until they're doing them quickly. And the challenge side, the challenge mode, is recall of very quick facts, so things like doubles, halves, and it's not working through levels as such. They can dip in and out of that one. So this is where it starts. It starts at what they call Rust, and it's very basic. You've got levels within that mode, and then those stars there represent how accurate they've been each time. That's an example of very starting levels. So you've got the blocks there, counting those blocks, and it's going to link to what Mr. Little is going to talk about in a minute with subitizing.
Just adding on to Numbots, although it looks simple for children at the start, it does get harder as the children progress through the levels. And I think at Courthouse we've only got 2 or 3 children that have actually completed Numbots, because there's so many levels and it gets a lot trickier. So really emphasising that to your children, that it will get harder even if they're a child that's competent in maths or is fluent already. That, like Ms. Godding said about speed and accuracy, are 2 things to really work on.
Just a quick one on Numbots as well. So children should have a login, a username and a password for Numbots, which is similar to their times tables, rock stars. login, and that should be in the front of their reading records. But if your child isn't sure about how they can log into Numbots, then you can check with their teacher. But we have been using it in the school as well, so children should be familiar with logging in and using the system.
So we talked about number bonds. I'm going to talk about how you can give children an opportunity to subitize. Subitizing is the ability to recognise a certain amount of something, and children do this a lot as they grow up and go towards reception age. What I mean by that, recognising a number as something else. On the screen now, there is a representation of the number 5. Linked to number bonds, so number bonds 2, 5 would be made up of 3 and 2. Obviously, in total there we've got 5. I'm sure lots of us will be able to recognise that as 5. That might be trickier for some children. So you can do this at home with anything, with peas, with beans, with the amount of chips, with counters, with bears, with cuddly toys, anything to make it fun and interactive for your children. Obviously, you can make it harder by adding more of what you're counting. You can group them, so 5 and 3 making 8, and that's a number bond within 10. You make it even harder with 3 different groups, so they're adding them up with 3 numbers. And again, it's about the speed of being able to do it, which is the most important thing. Children being able to do that makes them more fluent. So lots of practice for subitizing really helps with fluency. And there are different ways you can do it. It's not just counting things. On the bottom row, having dice to use. Obviously, we recognise that as 3 and 5. Having 2 or 3 dice and getting children to add up those numbers that are shown is a good way. Doing it on fingers, but not just doing it. I don't know if this will work on the screen in order. Not just doing it with 5 and 1 making 6, but you could do 3 and 3 or 4 and 2. Lots of different ways. Again, link it to the speed. Top left-hand side is what we call a 10 frame, which helps children visualize how many 10 is and how many are needed to make 10. So obviously we've got 4 counters out of order there. To make it easier, you could put those 4 counters in order, so all on the left-hand side, and then the child would have to work out how many's left to make 10. Nick, Becca, anything I missed out on subitizing?
I don't think. I think in school we just choose any opportunities we can. So I was giving the example earlier of on a daily mile walk. I'll be using my fingers and doing it. So it's just grabbing those opportunities when you can, short bursts of things. Okay, so we're moving on to times table facts now and practicing those to automaticity, getting that recall really quick. For times tables, we want children to understand the concept of multiplication first. So they need to understand that a number is being repeatedly added. On the screen, you'll see 3 add 3 or 3 add 3 add 3. And children need to understand that that is representing the multiplication there, the multiplication underneath. Times tables should also be grouped. So when they enter year 3 with us, we do expect children to already know their 2s, 5s and 10 times tables. They're the sort of base point, the starting point for children before we move on to other times tables. You can also group the other times tables together that are similar, so 3s and 6s because of their relationship, and 4s and 8s as well. It's a good link there to work on them together. Have I missed anything on that one?
No, we do it after Rockstars.
Lovely. So I'm sure again lots of you are familiar with times table Rockstars that we use in school and children use at home. Again, like Numbots, it's the same designers, the same company, and they really carefully designed the stages that children go through as they progress through times table Rockstars. All children are start on something called the auto training mode, which chunks the times tables into very small chunks at a time, and they work on those with multiplication and division before they move on. Again, like we said with the number bonds, it's about speed, so we want children to be answering and recalling facts within sort of 3 seconds, and yeah, I think that's probably the most important things there.
Yeah, I think with timetables there, I can see parents that have got children in kind of year 5 and 6, and it is about that speed. Timetables Rockers has those kind of levels of Rock Legend and Rock Hero that children work towards, and although it can, you don't just have to think about the classic times tables up to 12. Timetables Rockers does have an option to go up to 13 times table, and a bit higher.
Do 20s and 30s linked to them obviously knowing their 2s and 3s and things already. I think just one more thing on times tables. We mentioned earlier about in school a really useful way that we learn the times tables to start with, because times table rockstars can be used to practice them, but learning them we work on a counting stick. So we'll have a long stick with our post-it notes on saying sort of 4, 8, 12, and we will go through those and take some off as we go, really get them practicing forwards and backwards first before we have a go at things like times table rockstars. Times table rockstars and the questions that are on there are useful for practicing that speed, but they're not necessarily teaching them the times tables there.
Okay, so we've talked about number bonds and how you can verbally practice those with your children. We talked about subitizing, which kind of involves more kind of physical resources or fingers, and then how you can practice times tables, facts, to help your child become more fluent. Talk about now how parents can make a difference in making things, making all of what we've spoke about easy to do.
Yes, thanks both. Now, one thing about us at Courthouse is that we use a lot of educational research. So we do a lot of reading, we do a lot of keeping on top of most recent developments in educational research. And some of the interesting things I want to share with you today about what parents do that make a difference to children, particularly in maths. And the first one is avoiding things like this. Now, if we look at historically, I mean, Becca, Toby and I have taught for many years, and one of the most common things we see is when children struggle at maths, often talking to parents say these things and they believe these things. And of course, children are influenced by parents' beliefs and what they say, and therefore, if children are hearing these things, then they come to believe these things and they come to adopt those beliefs. And so it's really important to avoid negative language around maths, even if we might have had negative experiences in the past in our own school days. It's something that really does make a big difference. And we can easily switch this around. We can easily say something like, I worked really hard at maths when I was school, can kind of get you around to the same position. You might have found maths hard, but if you change the story about it, that you worked really hard at it, then that will be what your children learn as well. It's interesting to note who children listen to the most, and we like to think as adults that children follow us, but actually they follow their peers more, especially the older they get. They tend to imitate their peers. And so what we try to do at school is to make it normal to work hard, make it socially acceptable to work hard and to try and to enjoy learning. And that's really important as well in the home, in the family, to develop that kind of norm where working hard is what's expected, and that success comes from that effort. There's a few other things that I want to share here, and this is again, they're quite subtle things, but they do make a huge difference. The first one is what seems to make a difference is that parents who expect children to work hard at school, those children work hard. We all of us, children or adults, we rise or fall to the expectations that are set of us, and we know that when parents have conversations at home about what they should be doing at school, how they should be, how hard they should be working, and how hard they should be concentrating and listening to feedback from teachers. If those conversations are happening at home, we see a huge difference in children compared to if they're not happening at home. It's although children spend 6 hours or so a day at school with teachers. They spend far more time at home, and it's parents' expectations that seem to make a huge difference, and not just teachers' expectations. The second bullet point there is about taking an interest. Now, children will be more motivated. They will want to try harder if there are people at home who take an interest in what they're doing. And that's why we have questions in our weekly newsletter like this that give you something to hang on to. We write these questions, or teachers write these questions for you, so that you can physically pick them up and ask them, and expect a response from your child. And the reason we do this is because we know that when you ask a child, we've all been there, you ask a child, what did you do at school today? And they'll tell you about lunch or break time, or something interesting that happened with friends, but they might not always willingly give up information about what they've been learning. And so do make use of those questions in the newsletter each week, and even old newsletters to keep the conversation going and take that active interest in what they're learning at school. The third bullet point about checking engagement in schoolwork. Now, we have parents' evenings and reports kind of a couple of times a year, but that's not enough really for to be particularly meaningful. And checking engagement in schoolwork is simply similar to the second bullet point, where how hard you're working, are you understanding everything, in what ways do you show that you're paying attention? Like, conversations like this do help with children, particularly younger ones, to keep them focused and to keep the conversation about how important school is going at home. And the final one is really interesting. This one is about expectations of success. No matter what prior knowledge a child has, no matter what they already know and already understand, if parents demonstrate through their words and their actions that they expect their children to succeed and support them to do that, and to have supportive conversations, then children typically rise to that standard. And these are all subtle things that can be part of minutes of conversation a day, but they do really make a difference to how children achieve at school. Even though it's not at school when it happens, they do seem to make a difference to children at school. We've anecdotally, we've known this for many years from children that have performed the best at school. But I think it's worth sharing aloud, because they're small things that can make a big difference. The last thing I want to show you is some specific examples about things to do at home to help with children to develop their fluency and to enjoy maths a bit more. And this framework we like is quite useful for getting any child to do anything, whether that's maths homework, to read a book, or to eat more fruit, or to exercise more. We think these are the things that really do help changing habits. And the first is to make something easy. Now, if you imagine a situation where you want your child to log on to Numbots and do 10 minutes every day, if they have to get the laptop out of a cupboard, switch it on, realize that the battery's dead, find the charger, plug it in, turn it on, log in, find an internet browser, that can be maybe 10 or 15 minutes before they even get to doing the maths. And there are a number of barriers in the way to them doing what we want them to do. And so if we make it easy for them, the laptop's already set up, there's a bookmark for Numbots, the page is already open. These are the things that get children straight into doing what we want them to do, and therefore more likely to stick with habits such as 10 minutes of Numbots every day, or 10 minutes of Times Tables Rockstars every day. The A stands for attractive. We want to make, if we want children to do something, it needs to appear attractive. It needs to be, they need to want to do it. And one of the biggest reasons why anyone does anything is because they're good at it. Children or adults, we all tend to do more of what we're good at, and therefore the more we practice, the more success we have, the more likely it is we'll go on. Mr. Little, do you want to explain how Numbots does that for us? You're on mute, Mr. Little. Oh, it's been months since that's happened.
I'm out of practice. So Numbot starts really easily at the Rust level, kind of counting 1 out of 1 or how many beans are on the screen. It makes it really attractive because children, you get coins for every point you score, and then you can score, spend those points on Rockstars and Numbots in the shop, which children love. That kind of leads into the social element as well.
Yeah, another point on being social is that if you're doing some of the thinking with them, if you're flashing up fingers and saying how many fingers have I got and getting to sabotage, or if you're testing them on times tables or asking them about what they've learned at school, the fact that you're doing it with them makes it more likely that the habit will stick. And the last one is about being timely, and there are good times and there are bad times to get children to do things. If children are hungry, they're less likely to want to do something. They need to eat first. If they're tired, of course, they're less likely to want to do something. So we need to choose our moments carefully and make the most of little moments as well. So if you have, for example, if you have stairs at home, one really easy thing to do is to get into the habit of, say, counting in 3s or whatever times table they're working on as they go up the stairs. So every step, you say a number in a 3 times table, and they can even do it backwards on the way down. And switching that every now and then is a simple way to get them practicing a little bit very often, so that the kind of the number facts that we want to internalize actually do stick. One way to help that in the first instance is you might get post-it notes with numbers on, so they can actually read the numbers as they go up and down the stairs, and before you know it, they're in such a habit that they are kind of repeating numbers, which really helps to reduce cognitive load at school. So when they're asked to do harder problems, if they've got number facts to hand instantly, then they're far more likely to be successful with harder things at school. Toby, Becca, anything I missed?
No, there was an example of times tables on fingers as well, in not overloading children with, right, you have to learn all of the 6 times table up to 12 times 6 straight away, doing it on your fingers. So 6, 12, 18, just learning those 3 first, 6, 12, 18, getting children really fluent in doing that, and then adding 1 the next time, so 6, 12, 18, 24, also going backwards, so 24, 18, 12 and 6, helps them understand it more, helps them become more fluent, gets them to think about it more, which then helps them learn it in more depth.
Okay, so at this point now, we're happy to take questions. Any specific questions that we can elaborate on, or that we haven't covered?
Becca's going to answer one in the chat from Claire, which says, how are the apps monitored at school?
So all the teachers and teaching staff have access to both Timetable Rockstars and Numbots, and we can see lots and lots of data of what the children are doing. So we can see which level they're on, how many minutes they're spending on it. If they're struggling on a level, you can see how many times they've tried to attempt it. Things like the accuracy score percentage there. So there's lots and lots of data, and teachers check it regularly to see how we can help and what we can do to support children.
Teachers are able also to either take off the clock or slow things down if children are worried or find the time element tricky. Time element is there to promote a quicker recall, but we know for some children it worries them and they get upset or anxious if they don't answer it in a certain time. So if that is the case, let the class teacher know, and they can click a button which slows everything down. And
the jamming session on Timetable Rockstars is free of time pressure, so that is a useful one to use if children do find the time element hard to start with.
Teachers can also skip some of the easier levels. So if children are finding it really easy and it's not getting hard enough quick enough, then teachers can modify the level that children come in at, so that it's a more appropriate challenge.
If you've got any other questions, type them into the chat or feel free to unmute and ask.